So today we're going to be looking at a bit of a recap from what you learn about energy transfers and transformations in Year 8. We're going to recognise that energy can't be created or destroyed. We're going to explain common situations of energy transfer and transformation and describe how different forms of energy such as heat, light and sound can be transferred. We will need to recognise that the way that energy is transferred depends upon the medium it travels through. And we're going to define light as a type of energy that travels in the form of EM waves. And we're going to look at some of the properties of light and how light is transferred. So hopefully you remember that we have 8 different types of energies, and we can think of kinetic, heat, light, sound and electrical as a starting point. Kinetic energy is about how things move. So if anything's moving, it has kinetic energy. The faster it's moving, the more kinetic energy it has. So you can see that this bloke running, he's going to be moving with more kinetic energy than me sitting here with my computer in front of me. If we think about heat energy, you generally people think about feeling warm and the warmth that comes from the sun. So heat energy is that radiant energy that we feel from the sun. But we can also use that heat energy for things like hot air balloons, causing movement or melting something, so taking something that's quite cold and heating it up. But also all animals, you're emitting heat as you're sitting watching this video now. Light energy, so light energy comes from the sun. We also see light energy emitted from light globes and fires, and there are some luminescent animals, so some fish, and there's also glowworms and things which can emit their own light. Light we talk about as part of the electromagnetic spectrum, and we recognise that light behaves in a particular way. So light doesn't need a medium to be transmitted. We know that because we can see the light from stars in space. And in addition to that, we know that light travels in straight lines. You can see this just by looking in the mirror. So your reflection's not distorted as long as you're looking in a flat mirror, so light must travel in a straight line. But we also recognise that when we look at light, it behaves in a different way to other types of energy. And we'll look at that further later in the year. Sound. So sound energy is caused by vibration of particles. So your brain interprets those vibrations as sound. Those sounds can be things from voices or musical instruments, cars, power tools, but all of those things are things that really there's some sort of vibration. So maybe it's cymbals or a drum or something like that that's been hit to start the energy being transferred. Electrical energy, obviously you would really struggle to survive without it. Most of the electrical energy that we use in Australia comes from burning coal, but obviously we can generate from some renewable sources like solar cells and wind turbines and things like that. So I guess keep that in mind. Now, gravitational potential energy, this is the one where if you throw something up in the air, you know it's going to fall down, and you know it's going to fall down because there's some force acting. It has a mass that's going to pull it towards the Earth, and that mass is caused by gravity. So the higher the object is, the further it has to fall and the more energy it's going to transfer with. So if you think of a boulder being pushed off the top of a rock, of a mountain, it's going to fall down, and as it begins to fall, that gravitational potential energy is going to convert to kinetic energy as it's falling. So chemical potential energy is the energy stored in bonds in chemicals. So those can be in the foods that you eat. So when you're eating a sandwich or if you're eating a chocolate, something like that, your body is going to break down that energy. And by breaking the bonds, it's going to be digested in your digestive system and eventually the energy released to run your body. But in addition, we can talk about things like petrol. That's how we run our cars. And what's happening is we're putting petrol into the engine and allowing a combustion reaction to occur, and that breaks the bonds from the petrol molecule and releases energy to cause the car to move. Elastic potential energy, so this is the one about you stretch something and it wants to return to its initial shape. So things that are really stretchy are going to have more elastic potential energy. So things like rubber bands or a spring, those types of things. As soon as they're released, that energy is then released. It's converted to kinetic energy as it forces to return to its shape. So it undergoes, it removes that deformation that we've put in by stretching it in the first place or compressing it in the first place. You'll see that you can match up these different types of energies. So there are a few different examples. So you can look at kinetic energy, and you'll come through and you find that that's anything that's moving. Matches with kinetic. Thermal, we're talking about hot things. Nuclear, obviously nuclear power stations and things like that. Chemical in food, batteries, fuels. Sound, talking gravitational, is something that's up high. Elastic, we're talking about bungee jumpers and things like that. Electrical is anything that uses electricity, and light from light bulbs, candles, and things like that. Okay, the last part about energy is that we need to recognize that there's a law called the law of conservation of energy. And basically that law states that energy can't be created or destroyed. It all comes from the sun. That's where all the energy that we started with on the earth is from. And that then it's transferred either from one object to another or transformed from one type of energy to the next type of energy. Basically, that means that all the energy that we have started with us at the beginning of the universe, and it just passes and cycles around us. So being really clear, a transfer of energy means it's moving from one object to the next. Like when you throw a ball, you're moving the energy from yourself into the ball. But a transformation is talking about converting the type of energy. So if you're talking about throwing the ball again, then we're talking about the energy that your body's broken down in your food, which is then turning into kinetic energy as you throw that ball and move your arm. So we need to keep those things in mind. Obviously, even though the law of conservation exists, we see that sometimes energy appears to disappear. It doesn't really disappear. It's never lost, but we would state that it's wasted. So usually the wasted energy is heat energy. And if you think about, a TV or a computer or whatever, they all kind of heat up and waste a bit of energy. So it's important to recognize that there is wasted energy, and that reducing that is how we improve our energy efficiency in those types of devices. There's just a few examples that we can go through. So chemical potential energy being used in people as they move and as things fall down, or we dropped objects, they convert from gravitational energy to kinetic energy. So this little guy here, he's eating some food and his chemical potential energy is converting to his gravitational potential energy as he picks up the bar, and then when the bar falls, we go to kinetic energy. Electrical energy to light energy, so we've got our little power lines coming in, there are electrical energy, and when we connect up a globe to it, we can produce light energy. So there's our sun producing energy, the plant undergoes photosynthesis, and then somebody eats it and gets energy to do all types of different things. Okay, so here are a few more examples, but thanks for watching.